rectangle word problems. So again, quadratic word problems. We're going to look at some rectangles today that are a little bit more complicated. This one says, the length of a rectangle is 7 meters less than twice the width. Find the dimensions. The area is 60 square meters. Okay. I have an approach to these types of problems that that uses two variables, but we get rid of one of the variables right away. So this is technically a system of equations. However, I'm not going to solve it like we've been solving systems before. So I know that area is 60. I'm going to create my diagram here. Let's just say this is this is one side, right? X. I'm going to call that the width. Because the length, what I know about the length, right? The length equals 2 times the width minus 7. So technically I have this sort of other variable here, but what I'm going to do is I'm just going to write this instead of the length. So one side is x, the other side is 2x minus 7. I could have written like L and W, and then I could have said L equals 2w minus 7, and I could have used that as well. So there are many ways to solve this type of problem, but I think this is the easiest way. Before we do anything else, if we figure out what both sides of the rectangle are in terms of x. So I know this side is x, and this side is 2x minus 7. Then I can use my area formula. So again, the length times the width equals the area. And remember, this is the width, and this is the length. So 2x minus 7 times x equals 60. This is pretty similar to what we did yesterday and what you guys did last night. Yeah?
Can you put the x in front of the 2x?
Totally. And I would probably, write it like that normally, right? X times 2x minus 7 equals 60. It's the same thing. So either way you want to write it. The reason I'm being very deliberate about this is because we're going to look at another type of problem where it's not quite as obvious how we get the missing side. So now we practiced solving this sort of thing. We just distribute this. So we've got 2x squared minus 7x. And then make our quadratic equal 0. So I have 2x squared minus 7x minus 60 equals 0, which will now let me solve for x, right? Or w, whatever we wanted to call it, the width. So what do I have to do? Well, I have an a. So I can't just think of factors of 60 that add up to 7 because I have this 2 in the way. So I'm going to use Gary's terrific trick.
Yeah. Just times 2 times 60.
Good. And remember, this is just a trick. So 2 times negative 60 is negative 120. And now I have to try to think of factors of negative 120 that add up to negative 7. And I think this, we haven't talked a lot about this. Like when we have a large number, how do you find the factors?
If you factor it out and then you do different.
Yeah, there are different strategies. One thing that I like to do if I'm just like doing this and I have access to a calculator or a device with a calculator, I just type things in. 120 divided by 2. Okay, so that's 2 and 60. Or negative 2 and 60 or whatever.
15 times 8.
Okay, let me go through, you're totally right, but let me go through this process. Okay? And then I might say, oh, 2 and 60 are really far apart. So it's probably a number larger than 2. I might go, I wonder what 120 divided by 12 is. Well, that's 10. Okay, those are really close together, right? I need them to be 7 apart, basically. So it's going to be something in between the 2 and the 10, or the 2 and the 12. So then I would start trying other numbers. Well, 120 divided by 4, that would be 30. So we could have 4 and negative 30. Those are still pretty far apart. And then eventually, just by trying different numbers, I would probably figure out, just like Isa said, 8 times negative 15 is negative 120, and 8 plus negative 15 is negative 7.
You can also do it if you like pull it out and you go, you have 260 and then you pull out from 260.
Yeah.
You go
Yeah, we could like, we can kind of think of this
30
as
and 2.
30 and 2, and then like
3 and
move the
10.
2 over there.
And you have like 3 and 10 and then, or yeah.
Uh-huh.
you move the 3.
Yeah, and I really like this strategy if I don't have a calculator. I think with a calculator it's easier to just like try factors, but there is some, like what Dee Dee's saying is there's sort of some logic to this, right? There's some strategies that we can use. Like when you see 4 and 30, you might go, oh, I wonder about if we divide the 30 by 2, we get 15, and then multiply this by 2, we get the 8. So you can like move those little factors around in a way, and sometimes that will help you to find the answer. Yeah?
Wouldn't it also work if it was negative 8 plus 15? No, or negative 7? Because we had positive 15.
Let's look at it. Let's look at it.
15 is positive 7.
Yeah, so negative 8
Negative 8 plus 15.
and 15, this would multiply to equal negative 120, but would it add together to be negative 7? Negative 8 plus 15 would be positive 7. So in that case, it would not work. So it works for half of it, but it doesn't work for the other half. Okay, so I've figured out my factors right here. Now I'm going to rewrite, I'm going to kind of move up here. And I'm just going to rewrite this with those numbers instead of the negative 7x. So 2x squared plus, yeah, let's do minus first, right? We said that was easier. A lot of times it just helps us keep track of our negatives. Okay? Now I'm going to factor that by grouping. The only thing I can pull out here is an x. So I have 2x minus 15. I can pull a 4 out of both of these. And I have 2x minus 15. And then I pull out my block. 2x minus 15 times x plus 4 equals 0. Okay, so what could the sides of my rectangle be? Well, if 2x minus 15 equals 0, x would be 15 halves. If x minus 4 equals 0, x would be negative 4. Negative sides of rectangles are not something we want to pay attention to. So we're going to say that the side of our rectangle is 15 halves, or we could also write that as 7.5.
Why can't you just say it's like positive 4? Because you can't.
Well, positive 4 wouldn't be a solution to this, right? If x plus 4 equals 0, then x would equal negative 4. So positive 4 would not be a solution.
But on the other problems that we did, like on our homework, you have a negative, then they would just turn into
Right.
positive.
Let's see if that works. Let's see if that works here.
That's
Yeah.
because if you plug in that number into the box,
Right.
then it would always come up for the width to be that number.
Totally.
So it doesn't.
But like it
Uh-huh.
makes it that's because there's nothing in front of it.
Exactly.
Also, the
Yeah, so now we know that x is 7.5. Let's see. On all the other problems that we've done so far, Bella is totally right. The other side has just been the positive version of that. Does that happen here?
no, because you have to plug it in.
Let's see. Yeah, let's see. We have to plug it in, just like Bella said. So 2 times 7.5 minus 7. I should probably write that down here. 2 times 7.5 minus 7. That's 15 minus 7, which is 8. Huh. This is really interesting. Now we don't get this,
But
right?
it's
We get something totally different.
wait, Nate.
Yeah.
I have an observation.
Okay.
Okay, so when you double it, but
A was 2, so like this is like 2 times that.
The
I mean the
positive.
absolute value of that.
Yeah.
I actually don't know the answer to that. Like,
Can we
well, I mean
try
that's
it
a
with
great
three?
observation.
Can we try
I don't know if it will always happen. I have to show you one other type of these, but pay attention to that on your homework tonight, guys, because it's a really cool observation, right? And it would be a really, it'd be a really neat way to solve, yeah, to kind of check your answer, right? Let me just say something while I'm writing up this next problem. I just said the answer was 7.5 and 8, but really what we should write down is, right, the sides of the rectangle or the dimensions are 7.5 meters and 8 meters. Okay? So here's another type of problem. The area of a rectangle is 168 square centimeters. The perimeter of the same rectangle is 52 centimeters. What are the rectangle's dimensions? So this is where some of what I was saying before is going to start to make a little bit more sense, I think. If we draw a rectangle here, we really don't know anything about either side. So let's just call one side x, and let's call the other side y. Okay? The first step in these types of problems is to get rid of y, or get rid of x. It doesn't actually matter. And this is how you're going to do it. You're going to use the formula for perimeter of a rectangle. The perimeter of my rectangle is 2x plus 2y. How come 2x?
Because it's all the sides added together.
Yeah, it's really x plus y, right? That's the perimeter. That's how you've probably always solved perimeter, is you added all the sides together. But if you think about it in a rectangle, this side and this side are the same. And this side are the same. And I mean, my beautifully drawn rectangle is a perfect example of this, right? But in theory, in a real rectangle, this side would be exactly the same as this side.
Like on
So really, it's just 2 of these plus 2 of these equals the perimeter.
In theory, could it actually not be like that in a rectangle? Like one side could be more than another side?
That would be called a trapezoid. Yeah. So a rectangle, by definition, the sides across from each other are equal.
How is it a square?
Because the sides across from each other are equal, and
Not your
x equals y. Yeah. So a square is a special case of a rectangle. All right. So we can use this formula. We're going to use this formula here to kind of get rid of one of our variables. And here's how we do it. We know the perimeter. The perimeter is 52. 52 equals 2x plus 2y. Now I'm going to teach you kind of a trick here that I think makes life a little easier. I like to divide everything by 2 at this point. So I'm going to divide everything there by 2.
Is this an actual thing that like mathematicians use? It's just
Uh-huh.
what you read about?
Well, I mean, everyone would have a kind of a different strategy for solving a problem like this. I just think this makes it a little easier. And I want to isolate y. So now I know if I subtract x from both sides.
Why do you want to isolate y?
I just want to isolate one of the variables, and I
So
prefer
you
to have
can
x.
plug it in.
Yeah. And so then I take the 26 minus x right here, and I put 26 minus x up there. Because I know that y is 26 minus x. You guys see that? So before I do anything else, I have both sides of this rectangle in terms of x. Okay? I'm using that perimeter to just figure out what this side of the rectangle is. Okay, now I just go back to the process we were doing before. So the length times the width should equal the area. Remember, my area in this case is 168. So I have x times 26 minus x equals 168. Distribute the x, but I'm going to write the x squared term first. So it's negative x squared plus 26x equals 168. I just switched the order of the terms there. Now I subtract 168 from both sides. Negative x squared plus 26x minus 168 equals 0. I'm going to just rewrite that up here. Negative x squared plus 26x minus 168 equals 0. Here's another hint, and we actually did talk about this when we were factoring, but if you have a negative in front of x squared, it's easier to just get rid of it. So that's what I'm going to do. I'm going to divide both sides of this equation by negative 1. Okay? That's going to give me a positive x squared minus 26x plus 168, still equaling 0. So I'm getting rid of that negative in front of x squared.
0 is not positive or negative.
Yeah, 0 is not positive or negative. I could multiply by negative 1. I could also add x squared, subtract 26x, and add 168 to both sides. But the idea is that I'm just flipping, right? I'm flipping all the negatives. I'm flipping my signs. So I'm flipping the negative x squared to a positive x squared, flipping the positive 26x to a negative 26, flipping the negative 168 to a positive 168, and 0 flips to 0 because it's neither positive nor negative.
So,
Yeah.
I mean, on homework, do you want us to actually show, like, oh yeah, we multiplied by negative 1, or can you just
No, you can just kind of do this step by step, like flipping your negatives.
And then
It's something that comes up a lot, actually.
And then in any problem, like not even this kind of math, just in anything, you always want x to be positive, right?
You really want x squared, your x squared term
Yeah,
to be
yeah,
positive, yeah, with a quadratic. But if it didn't equal 0, I couldn't do this, right? If it didn't equal 0, I can't just get rid of the negative 1. So when it equals y, I can't get rid of the negatives. And that's why those, remember when x squared was negative, the parabolas were upside down like this. All right, so now I have to try to think of factors of 168 that add up to negative 26. So first of all, are my factors going to be positive, negative, or one of each?
No, both negatives.
Both negatives, exactly. I'm going to have two negative factors. So I'm looking for two numbers that add up to 26. And I would just take my calculator and start dividing. got to turn it on first. 168 divided by 2 is 84. Do those numbers add up to 26? No. How about 168 divided by 4? That's 42. Those don't add up. How about 168 divided by 8? 21. That doesn't work. Okay. 168 divided by... Notice that our number is still too big. 8 plus 21 is 29. So I still want to try to get like a larger factor here. I could try like 6 and 3, but they wouldn't work because the numbers are still going to be too far apart. I need numbers that are closer together. There's like kind of a pattern to the way that factors work. Yeah?
14 and 12.
Oh, 168 divided by 14 equals 12. And remember, all of these are technically all negative, right? So negative 14 and negative 12. Oh. Negative 14 and negative 12. So I have x minus 14, x
But then both of them
minus 12 equals 0.
Because the 26 is the two terms added together, not.
So yeah, this is another really interesting thing. X could equal 14 or x could equal 12. wait a second, neither one of these answers is negative. So I can't cross it out. But wait, 26 minus 14 is 12.
What?
So those are my two answers.
And,
Because if I plug 14 in, then I get 12 for the other side. If I plug 12 in, I get 14 for the other side. So my answers are, well, the dimensions could either be 14 and 12, or 12 and 14. That's the same thing.
Always gonna be true.
Same thing.
With these kinds of problems.
You know, I actually don't know the answer to that. I think so.
That's another extra step.
Yeah. I think it will always be true for problems like this one. But I don't know if like all perimeter problems always end up like this. I'm not sure about the answer to that. Because if you think about it, like you could theoretically, I don't know if this would ever happen, but you could end up with a number like 30. And then when you subtract 30 from 26, the other side would be negative. So that wouldn't work, right? So you could eliminate that set of answers. I don't know if that ever happens or not. All right.
Ding, ding, ding.
Ding, ding, ding.
I love